purpose of this video is to introduce you to our newest transformation called the dilation and teach you how to construct some dilations. So first of all, what is it? A dilation is a new kind of transformation that will produce an image that is the same shape as the original image, but is of a different size. So in other words, it's going to take and it's going to enlarge or shrink the original figure and will produce something that's similar to the pre-image. So my first question for you is a dilation an isometry? What do you think? Well, an isometry is any transformation that preserves length or preserves distance. And because the new one is of a different size than the original, the dilation is the first and only of our transformations that's not an isometry. So that makes him kind of special. Not an isometry. Now, in order to describe a dilation, we have to talk about something called the scale factor, which will tell us how big or small to make the image, and the center of dilation. The center of dilation will be a fixed point in the plane about which we contract or expand all of the other points. It's important to note that he's the only invariant point under a dilation. Remember that word invariant means does not change. So that center of dilation is the only fixed point that does not change when we dilate an object. Well, let's go ahead and find some dilations and some scale factors in example 1. Number 1 says to first of all identify the dilation and find its scale factor. Dilations we're going to indicate by using the capital letter D. So D is going to stand for dilation. Mathematicians are not always all that original. We have to talk about which point this image was dilated through. And if we take a look at the picture, we can identify the point or the center of dilation simply by connecting each image with its original. And if we follow each image back through its original point, each and every time we'll end up with point O, and that's going to be our center of dilation. And then we need to decide on a scale factor. If we take a look at the picture, we notice that the image, which is triangle A prime, B prime, C prime, is considerably larger than the pre-image, what we started out with, triangle A, B, C. And in order to find our scale factor, what we're going to do is we're going to run a couple comparisons. We're going to compare the length of, or the distance from point O, our center of dilation, to point C prime. And we're going to compare that to the length of O, our center of dilation, to where that point started out, C. So if we take the distance from point O to C prime, that distance is 6. And we want to compare that to the distance between O and C. That distance is 2. And I want you to notice that this distance here has been multiplied times 3. That's going to give us a scale factor of 3. So you're always going to compare this or find the scale factor by comparing the new or the dilated image to the old or the original or the pre-image. So this is a dilation through center O of scale factor 3. Notice that a scale factor of 3 will result in an image that is larger or is an enlargement of the pre-image. All right, let's take the same idea and go take a look at letter B. This one we notice is a dilation, still through center O. That part hasn't changed. But now we need to find the scale factor. So in order to find the scale factor, I'm going to compare the new one, so the distance from center O to point C prime, with the original, the distance from O to point C. So distance from O to C prime is 2 centimeters. Distance from O to C is 5 centimeters, making our scale factor in this case 2 to 5. The ghost is on my computer at it again. Let's see if we can get rid of some of the ghost's work. And apparently the ghost does not want to go away. All right, hopefully I vanquished the ghost here. We were saying the distance from O to C prime is 2. The distance from our center of dilation to our original point C was 5. And that's going to make our scale factor here 2 to 5. Notice that this is a reduction or a shrinking. O to B prime is much smaller than O to B was. And notice that the scale factor in a reduction or a shrinking is going to be something less than 1. All right, we need to talk about scale factors here just for a minute, just to clarify. Scale factor in the original was equal to 3. And what you need to be aware of is that sometimes the scale factor can be written as a ratio. Written as a ratio, a scale factor of 3 is going to be 1 to 3, where we're comparing the pre-image or the old to the image or the new one. So a ratio of 1 to 3 would result in an enlargement that is 3 times bigger than the old one, or a scale factor of 3. Over here in this particular example in part B, the scale factor is 2 to 5. But if we were to write this as a ratio, the ratio is always going to compare the old one to the new one. And since the old one was larger, we would have to write that as 5 to 2. And again, we're comparing the old one or the original one, which was larger than the new one. So just be aware that you might see that scale factor written sometimes as a whole number or fraction. You might see it sometimes written as the ratio. And if you see it as the ratio, know that it's comparing the original one to the new one, or the pre-image to the image if you want to talk math terms. All right, down in example 2, it says use a compass and a straight edge in order to construct the following dilations. All right, so this will be fun. So part A says construct the dilation through center O of scale factor 2 of line segment AB. Well, in order to do this, I'm going to go ahead and grab my compass and straight edge. I'm going to start by drawing a nice ray that starts at point O and passes through point A. And I'll construct a second ray that starts at point O and passes through point B. Now this is telling us we want to use a scale factor of 2. So we want the new distances to be double the lengths of the original distances. I'm going to go ahead and grab my compass out of my backpack. You should grab yours at the same time. Remember, the compass is our measuring tool or our measuring instrument. And what I really want to do is I want to start by measuring the distance from O to point A. I want to make my new distance exactly double that. So I'm going to go ahead and mark off another segment of length OA, this time with its center at point A. And that spot where the arc intersects my ray will become my new A prime. Now my distance from O to A prime is exactly double the distance of O to A. And then I'm going to go do exactly the same thing, but for point B. I'm going to use my compass to measure the distance from point O to point B. And then I'll use my compass to go mark off a second segment with that same length. And where that ray intersects my arc, that becomes my B prime. So now my distance from O to B prime is double the distance from O to point B. I'll grab my straight edge and go connect points A and B. And there's my new line segment, A prime, B prime. Now the new line segment you can see is an enlargement. It's much bigger than the original one. So that scale factor of 2 tells me that the new one is twice the length of the old one. All right then, the last example down at the bottom wants us to construct a dilation through center O of scale factor 1/2 of triangle ADB. Like I did in the first example, I'm going to go ahead and start by constructing these rays. Actually, since we're doing a reduction here, I'm going to use line segments. we want the distance from O to A prime to be exactly half of what the distance from O to A was. So I need to use the construction that'll let me find halfway, or the midpoint, of O to A prime. And the construction that allows me to find midpoint is, of course, the perpendicular bisector. So I'm going to go ahead and construct the perpendicular bisector of O to A prime, or sorry, O to A. And I didn't get quite long enough with my first arc, so I'll go back and finish that. And I'm going to do these perpendicular bisectors in a dotted ray, because the only real reason I want that perpendicular bisector is for the purpose of finding the midpoint. So that midpoint is going to become my A prime. To find the image of D, I'm going to go ahead and construct the perpendicular bisector of segment AD. And I guess this construction I'll do in red just to differentiate from O to A. And this one too I'm going to do with a dotted ray, because my only real purpose in doing that construction is to find the midpoint. So the midpoint of that line segment is going to become my D prime. And then just to be beautiful, I'll make my last construction in green, and that's going to become the perpendicular bisector of segment OB. All right, I'm trying to do this one in green. There we go. Spin it around. Oh, and apparently I wasn't quite long enough, so I'm going to have to start that construction again and extend my compass setting just a bit longer. And this time I should have it. Flip that around. And again, my only real purpose here in constructing the perpendicular bisector is to find the midpoint of that line segment. So that's going to be my point B prime. So now in order to create the triangle, I'm just going to connect point A to D prime, point D prime to B prime, and then B prime back to A prime. And my new one is exactly half the distance from point O as my old one was, which is why the scale factor there is 1/2. All right, like yesterday, I'm going to have you go ahead and flip to the next page and check your understanding. Again, I want you to think about what were the key ideas that you watched. What are the important understandings that you're going to need to take away with you from this video? And then you can go ahead and answer the questions and make sure you're ready and able to apply what you've learned. As always, if you have any questions, feel free to write them down in the margins, and we'll chat about them the next time you come back to class.